Finding the area of circles. In addition to being able to find the circumference of a circle, we always want to be able to find the area of a circle. We have a simple formula for that. The area of circle is equal to pi times the radius squared. And this will be the formula that we use for all three of the examples we're about to do. In our first circle, we have a circle that has a radius of 2 inches. We already know what the radius is. So if we're finding the area of circle 1, we'll say the area is equal to pi times the radius squared. I know what the radius is. It's 2. So I'm finding pi times the radius squared. This is equal to pi times 4, and I will use 3.14 as my approximation for pi. 2 squared I know to be 4, and when I multiply these together, I get 12.56. Now the labeling is going to be important on this. I know that I've labeled in inches, so I want to be careful to label this as well. I don't just label it 12.56 inches, but 12.56 square inches, since that's how we always label area. There are 12.56 square inches of area in the first circle. In the second circle, we're not given the radius, we're given the diameter, and our formula calls for us to know the radius. So the first thing I have to do is find the radius, which I know is 1/2 of the diameter. So I'll find the radius is 1/2 of 26, or 13 feet. That will be the radius that I'm using in my problem. I'm going to use my formula, area equals pi r squared. So I'll have area equals 3.14, the approximation I've chosen for pi, times 13 squared. That tells me I need to multiply 3.14 times 13 squared, which is 169. I'm going to use my calculator to help me do that. So I'll make sure I clear this out and take 3.14 times 169. So I have 530.66. And I come back and I know my problem is 530.66, I'm checking my label, square feet. Our last diagram represents the problem that we have here. The zoo has a 6-foot walkway around a circular seal pool. What is the area of the walkway? If you look at the diagram, you'll find the walkway is represented by the gray or shaded area. We've got the walkway going all the way around the pool, and the pool is represented by the white inner circle. We're going to have to be kind of tricky in solving this problem and think about how to solve it. If I could find the area of the entire large circle, as if this were solid, I could find the area of the entire large circle, and I could find the area of the smaller circle, I could take the area of the large circle minus the area of the smaller circle, and that would leave only this ring around the outside, which represents the walkway around the pool. So I want to start by finding the area of the larger circle. And I know I'm going to use my formula, area equals pi times the radius squared. So for the larger circle, I'm going to use the area is equal to pi times the radius squared. Now I have to think about what the radius actually is. I know that the radius of the whole circle is not 6 feet. The radius goes from the center of circle to the outer edge of the circle. If I look, I know the radius of the inner circle is 40 feet, and I know that the radius is 40 feet no matter where I draw it in the circle. So I'm going to draw a radius that goes from the center of this circle to where my little segment of 6 feet starts. I know that this radius is equal to 40 feet, and I'm going to add on 6 feet to get to the outer edge of the large circle. So my entire radius is 40 plus 6, or 46 feet. So I know the larger circle is pi times 46 squared. Crossing to the calculator, I'll use 3.14 for my approximation for pi times 46 squared. And when I hit equals, I get 6,644.24 square feet. So I have 6,644.24 square feet for the area of the larger circle. Now I need to find the area of the smaller circle. If I look at the smaller circle, I know I'm going to use the same formula, area equals pi r squared, and I'll have area equals pi times the radius squared. The radius of the inner circle is only 40 feet, so I'll have times 40 squared. Using my calculator, I can put in pi. I'm going to put in my approximation for pi. So I'll start with a clear calculator and say 3.14 times the radius squared, which is 40 squared. And that equals 5,024 square feet. Now I have the area of the larger circle and I have the area of the smaller circle, and I need to take the larger one minus the smaller one to find the area of the walkway. So for the area of the walkway, I'll take the larger circle, 6,644.24 square feet, and subtract the smaller circle, 5,024 square feet. So I'll take 6,644.24 square feet minus 5,024 square feet, and I'll get my final answer, which is 1,620.24 square feet. I need to remember exactly what it is I've found. I have found the area of the walkway going around the seal pool. I took the area of the larger circle minus the area of the smaller circle, which left the area of the surrounding walkway, which is 1,620.24 square feet. Using problem-solving skills in tandem with the area formula can help you to solve many more complicated problems.
This is a piece of 1/2 inch galvanized pipe. This is a 1 inch piece. The 1 inch is twice the diameter of the 1/2 inch piece. Figure out in square inches the area of each piece of pipe. Let's find the area of these two pipes. Area equals pi times radius squared. Now the 1/2 inch pipe, that's the diameter of the pipe. So we got to have 1/2 of 1/2, and that will equal 1/4 or 0.250, and a half of 1 inch pipe is 1/2 inch or 0.5. So let's just plug in the numbers. Area equals 3.14 times radius is 0.25. You don't have to bring in the 0. And then we'll find the area then for the 1/2 inch pipe. So it's 0.25, and we'll just do x squared, times 3.14 equals 0.196. We'll just round it. That area goes 0.196. Find the area for the 1 inch pipe. So that will be A equals pi is 3.14 times the radius is 0.5 squared. Clear the calculator. 0.5, and let's do it the other way, times 0.5 times 3.14 equals A equals 0.785. Let's go back to the video where I ask another question. Now that you've figured the area of the 1/2 inch pipe and the 1 inch pipe, the 1 inch pipe is twice as large in diameter as the 1/2 inch pipe, how many times does the area increase? Or we can also look at how much more flow flows through the pipe when the pipe is increased twice in its diameter. I have the area for the 1 inch pipe is in the calculator, 0.785. Let's divide the area of the 1/2 inch pipe into that number. Remember, we rounded this number, so it's going to be a little bit different. So divide that number by 0.196 equals 4.005, or 4 times. In other words, this 1/2 inch pipe compared to the area for the 1 inch pipe increases, I shouldn't put an equal, 4 times. When you increase the diameter 2 times, the area increases 4 times. Let's see if that holds true for this. I have a piece of tubing here which measures, this is PVC, plastic tubing. This is 1.5 inches, and this is a piece of 3 inch tubing. Now let's see what the area of this, between these two tubings, also increases 4 times. So we'll just get the formula then. Area equals, it'd be 3.14, and so for the 1.5 inches, the radius will be 3/4 of an inch, or 0.75. And let's find the area of the 3-inch pipe is 3.14 times the radius, that's diameter, would be 1.5 inches, or 1.5. Let's find out what it equals, the area. Let's do the 1.5 inch first. 3.14 times 0.75 times 0.75 equals. So the area equals 1.766. Let's do the area for the 3-inch pipe now. Clear the calculator. 3.14 times 1.5 times 1.5 equals, and that area equals 7.065. Let's divide that now by this number. So all we have to divide then is that number, 1.76 into that number. Divide by 1.766 equals 4 times also. I forgot to put the square over here, but that's understood there. So if this is 1.5 inch in diameter, and this is 3 inches in diameter, it also increases 4 times. So as you can see, whenever the diameter of piping doubles, the area increases 4 times. This is a Brahman bull at the Houston Livestock Show and Rodeo. They were selling a Brahman bull for $40,000. One of the most important issues for cattle breeding is the meat the cattle will produce. The L2 Beefmaster Ranch had a booth at the Houston Livestock Show and Rodeo. They were advertising these cattle that you see displayed. It was rather interesting to me when I went to the Houston Livestock Show and Rodeo when I came across this article, Carcass and Ultrasound. And in this article, they had this math problem that the ideal ribeye should measure between 11 and 15 square inches. So what we want to find out, what should that diameter be for that ribeye? That mouth-watering ribeye where they can sell it and get the most money for the cattle. And a bull, that's why they pay so much money for a bull, it can mate between 30 to 50 cows a year. So they spend a lot of money to get these ideal ribeyes. So when the cattle go to market, they can make more money with them. But let's find out what is the diameter for the 11 square inches and the 15 square inches. What should these two diameters be between here? That's the ideal size, the ribeye, what they want from the cattle. So area equals pi times radius squared. And we want to find the radius. Then eventually we get the diameter. So divide each side by pi. So radius squared equals area divided by pi, which is 3.14. And the area is 11. Let's work with 11 first. Divided by 3.14 equals radius squared. So let's go to the calculator. Clear the calculator. Area is 11 divided by pi, 3.14 equals 3.503. So 3.503 equals radius squared. And all we have to do is get the square root from each side and isolate the radius. So radius will equal, just press the square root button on the calculator, is 1.87. And we want to know the diameter. We want to know the diameter, so all we have to do then is multiply that by 2 times 2, and diameter equals 3.74 inches. Well, let's find what is the 15-inch square inches. Area equals pi times radius squared. And again, we want to isolate the radius squared, so by each side. So radius squared equals a over pi, and that will equal then 15 divided by 3.14 equals radius squared. Let's clear the calculator. That's 15 divided by 3.14 equals 4.77 equals radius squared. We find the square root for each side. Press the square root key. So the radius is 2.185 or 2.19. So radius equals 2.19. And the final diameter, all we have to do is multiply that by 2, and that will equal 4.37 inches. So the ideal ribeye should measure from 3.74 inches in diameter to 4.37 inches. And as you can see, even in raising cattle, you're going to have to know how to work with formulas, just like we're studying here. And I got this out of this article here, and some people might think if you're raising cattle, you wouldn't have to know algebra and geometry, but as I've just proven to you, you have to know these things, and you never know in what fields you go into where knowing algebra, geometry, and even trigonometry, that will be required for you if you want to get ahead.
Please pause the video now and complete the problems in your workbook. When finished, press play, and we'll continue with the next lesson.